Suppose that we fill up our car with gas. What type of energy does this gas possess? There's two S's in possess, so I made sure I put that there. So what type of energy does this gas possess? This would be chemical potential energy. How do I know that it is the chemical potential energy? Reason we know that is recall from grade 11 our basic definition of what potential energy is. And recall that potential energy is stored energy in an object that can be stored or can be transformed, into some other form of energy. So the gasoline has chemical potential, could be possibly transformed into kinetic energy to move the car. Let's say we stretch a rubber band out long, that has elastic potential energy to restore to its original shape, etc. Remember as well from grade 11 mechanical energy, and when we talk about mechanical energy, what does that mean? We are talking about the sum of an object's kinetic and potential energies. And let us now look at a specific form of potential energy, and that is the gravitational potential energy. Which we will use EG for short. It is the stored energy an object has because of its position. And the applied gravitational force. Recall when lifting an object, the work done is calculated. How? Well, we can calculate the work done by taking our work, which is measured in joules, and set it equal to mg delta y. And just recall, m is our mass of the object in kilograms. G is the acceleration due to gravity, and that's 9.81 meters per second squared. And y is our vertical displacement. We can say that the work done when lifting an object is transformed into gravitational potential energy. So therefore, our change in gravitational potential energy is equal to mg delta y yet again. And the key thing here is that this will be our vertical displacement of an object relative to a reference point. Note, just something to be aware of, is that this equation is valid only if, or only for, sorry, situations where the change in height does not drastically change the value of g, being the 9.81 meters per second squared. So there's more of like the theory, more of the stuff that we need to know for gravitational potential energy. Let us look very quickly at two examples. We see in example 1 that a box of books is being lifted 0.75 meters from the ground to the back of the truck, and increasing the gravitational potential energy by 88 joules, and we're calculating the mass of the books. Remember that if we have this box of books that's on the ground, relative to the Earth, the gravitational potential energy of these books will be 0 joules. When we lift it to 0.75 meters, that is where we get the change in gravitational potential energy in this case, and that is by 88 joules. So going ahead and calculating the fact that we have our gravitational potential energy of 88 joules, our change in the vertical displacement of the object relative to the Earth is 0.75 meters. We know that g is 9.81 meters per second squared. Let us calculate the mass of the books. I'm going to all the time interchange delta y and h. It's the same thing in this case. So let's calculate this. We're looking to solve for m, so we must divide by gh on both sides of my equal sign. So the mass will be the change in gravitational potential energy over gh. So let us calculate that. That will be 88 all over 9.81 times 0.75. Got my calculator. 88 divided by, we have 9.81 times 0.75. Let us see what we get. 11.9605. 06 in this case. Now, how many significant digits? 88 joules has 2 significant digits. 0.75 also has 2 significant digits. 11.9 rounds to 12 kilograms for the mass of this box of books. A second example. In the case that we have a weightlifter raising a 75 kilogram barbell. Well, there's one piece of information. Our mass is 75 kilograms. From his shoulders to a position 0.45 meters above his shoulders. So h is 0.45 meters. How much work is done? And recall that work is mgh when we are lifting an object. So that will be 75 times 0.45. My apologies, G is 9.81 times H of 0.45. So 75 times 9.81 times 0.45. 331.0875. And let's look quickly again. Two significant digits each time. We have to figure out, is 331 closer to 330 or 340? In this case, 330 joules of work is done. Remember, trailing zeros after two non-zero digits is not significant. So that's why this answer here has only two significant digits. This answer as well, we got 330 joules. That's the work done. This is also the gravitational potential energy of the barbell relative to the shoulders. Two examples, not too bad. If you're having any troubles, always make sure you email me and I can give you a little bit more of an explanation if needed.